Okay, I'm recording.
Very cool. Yeah, everyone, I would just wait like 2 minutes in order to everybody to join the call, since many guys answered to my messages on Discord. So I would wait like 1 minute, and then we will start.
Hello, everyone. Can you hear me?
Yep.
Hello, Gabriele.
Hello, Ahmad.
Great, great. You can hear me. I was waiting for a confirmation. All right. We'll wait.
Just checking with the people who answered to the call to see who is missing. Udini, you are 50 sats, right? On Discord.
Yes, please. Good
Okay,
evening,
cool. Okay, we are 9 people. I think that we can start. And let me share my screen. Okay. Can you see my screen?
Yes.
Okay. So if Plebesh, can you confirm you are recording?
Yes, I am.
Okay, so if everybody of you could just switch off your mic, it would be nice. Okay, great. Because Lorban, could you switch off your mic? Okay, sorry guys. So, as we already said, we are going to record the session for future newcomers. So, if everybody is okay, I would proceed. So, here we are for this introduction call about Stratum V2, in particular our SRI project. So, we prepared a set of slides in order to align everybody here about what is actually Stratum V2 and what is the context around Stratum V2. So in order to let everybody be more informed about the context in general. So this is our agenda of today's call. We will do an introduction, a very general introduction about Bitcoin mining. We will explore the past pooled mining protocols. Then we will dive into the project of SV2, and then we will dig into how to contribute to SV2, explaining who will be the mentors, what will be the sub-projects and some reference material. So we will start with the introduction to Bitcoin mining. So first of all, I hope that everybody here already know something about Bitcoin, but just to be totally aligned with everybody here, what is Bitcoin? Starting from its white paper, it is a peer-to-peer electronic cash system where there's no need for any financial institution. So through a system of digital signatures and a lot of other stuff, it constitutes finally a solution to the double spending problem, and in particular through the usage of the proof of work algorithm. So what is proof of work? It is a concept which was inherited from Hashcash by Adam Beck in 1997, in which basically that system was a way to add a physical cost by the electricity consumption to send emails in order to fight the spam that was there during those years. So a very similar approach was inherited from this Hashcash system, and it is the proof of work used in Bitcoin to solve the double spending problem, as I mentioned before. So also on these slides, you will find some references if anybody of you will be interested in diving.
Sorry, Gabriele, I can't see any slides. Can others see? Can't see anything. Oh.
Can you say if everybody is right for the others?
That problem, that's it.
Okay. I don't know. Try to re-enter again, maybe.
It's all black for me. Okay. Anyway.
Try to go out and get in.
Okay. Again. I'll. Yeah, I'm with the phone, so it doesn't work with the phone, right?
Yeah, try with a laptop.
Okay. I'll need to go upstairs. All right. Go on. Sorry, Gabriele. Go on.
Yeah, for this kind of question, maybe before write on the chat. Since we are recording, we will prefer this behavior. But by the way, as I was saying, Bitcoin mining is an activity made by two main components. The first one is the block templates assembling. As you can see in this part of the slide, there is a Bitcoin block built with a block header and the list of transactions included in this block template. I underlined here some very important parameters of the block header, such as the difficulty, which is basically the target which needs to be satisfied from proof of work in order to be a real block. So in order to satisfy the difficulty of the network and be a valid block. And here there's the nonce, which is basically a 4-byte parameter, which is constantly changed by the miners in order to try to find this solution to the proof of work. And here, as I underlined, there's the list of all the transactions included in the block, which will be included in the eventual valid block. And inside of this list of transactions, there's one transaction which is called the Coinbase transactions, which basically assign the block reward to the winning miner. And this is, of course, the main incentive for the miners to do that and to spend energy and whatever. But after the block templates assembling, of course, the miner take this data and start double hashing with the double SHA-256 on the block header until the value, which is the output of this double SHA-256, satisfy the network difficulty, as I said before. So here, the difficulty target is just a number, and you take, after having the block assembled, you take the block header and you do double SHA-256 until the output will be a number which will be lower than this difficulty target. So here on the right, you can see a flowchart of the mining activity, which basically tries to wrap up all what a miner does. So, but what happens if more miners enter the game, enter the network and start mining? Here on the left, you can see how the Bitcoin mining difficulty has changed during, since the beginning, basically. And how it is that there's a mechanism in Bitcoin which is called the difficulty adjustment, so that every 2016 blocks, if more miners enter the game, the difficulty has to be rise. So that difficulty target will be lowered in order to be to find a valid proof of work with more difficulty. So And of course, it works also on the contrary. So if there are less miners than before, the difficulty has to be lowered. So the difficulty adjustment mechanism just put the target at a higher level. And yeah, you can see that since the beginning, since 2010, when the GPU area started, the difficulty chart just skyrocketed. And on the right of this slide, you can see, for example, one ASIC miner, one of the most powerful machines in the market right now, which is capable of doing like 250 terahash per second. So that was just to better to give you some real numbers. So what happened in the past? In the first years, in the early days of Bitcoin, of course, every miner was mining, doing the so-called solo mining. So basically, with just his laptops or GPUs, every miner was working alone in order to get the entire reward by itself. But as we have just seen, there's this difficulty adjustment mechanism, which got all the things harder during the years. So a way to better manage the cash inbound of every miner without waiting like weeks or months before getting a new block, a new valid block, was found. And it basically, it's the meaning of the mining pool and the so-called pooled mining. So right now, the 99% of all the mining activity in the world is doing it this way. So individual miners, which are geographically distributed maybe all over the world, try to solve the proof of work that we seen in some slides ago by aggregating their relative hash rate with other miners. And they do this like just exploiting the fact that every miner are mining on the same pool address put into the Coinbase transaction, so that the reward is collected because every miner is working, basically rewarding the same pool address. And then once a block is found, the block reward is assigned to the pool, and in another time after that, the reward is distributed among the miners accordingly to the hash rate they put in the pool, of course. But in order to manage all this communication between individual miners and mining pool operators, a pooled mining protocol is needed. So now we will start the discussion about the past and the present pooled mining protocol.
Excuse me, Gabriele, what's the benefit of using pooled mining as opposed to, just the solo one?
Yeah, the benefit is just that right now it's almost impossible to find a block alone. I mean, even if you have like 20 machines or 100 machines, you will have to wait a lot of time before getting to find a real block, because the difficulty is so high that you will need to wait a lot of time. But in the meantime, let's say you have 1,000 machines, you are paying for all the electricity you are consuming. You need to pay the machines, so you can't wait like months before getting a new block alone. So in the meantime, what do? You join the hash rate you are getting from your 1,000 machines with other miners in other parts of the world, so that you will find together a block sooner, so that you will be rewarded, of course, not entirely, but just the share that you contributed to the pool, but without waiting many days, weeks, or months. So that's the reason why the pooled mining activity started at first. I hope to have answered enough.
Yes, thank you. I got it. It's basically more efficient, if I got it correct.
Yeah. You can do business basically because you can be reliable onto paying for your electricity monthly and to pay your machines without waiting and fighting with the intrinsic lack of the proof of work game into Bitcoin. So in order to coordinate all these activities, some protocols would be needed. And since the beginning in 2010, the get to work protocol was proposed and used, and it was basically a JSON RPC method sent over HTTP. And it provided a block header that we mentioned before. And the miners basically were just changing the nonce or the timestamp field into the block header, trying to find, of course, a valid block. But they, of course, would need to do many requests to the server to provide new block header to work on. And that's the reason why 2 years later, in 2012, basically some new protocols were developed. And at first, the protocol called Get Block Template was proposed, and it was very, very flexible in comparison with the other Get Work. But it, of course, it permitted also a customization of the block template miner side in a similar way we will explain it is doing Stratum V2. And other customization, but by the way, it was really too complicated to be fully implemented at first, and so to be adopted from the pools and the miners themselves. So that's the reason why the actual pooled mining protocol, which is used nowadays, is the protocol called Stratum, that we will call, of course, Stratum V1, in order to distinguish to our Stratum V2, but it is just called Stratum. And it is, again, a JSON RPC protocol. So the messages between each exchange between the pools and the miners are JSON RPC messages sent over TCP socket. And of course, it is the protocol which is used and which was adopted during 2012 instead of Get Block Template, because it was very, very efficient and very, very simple without many messages and stuff like that. But by the way, it was lacking about some security measures and authentication too, since it's basically plain text without any encryption at all. And the other bad aspect about Stratum is that it gets a centralization risk, since, as we will explain later better, the transaction selection, so the transaction which goes into the block template, is done by the pool operators. And I just go to the previous slide here, where we have seen that there's the list of the transactions, which of course fulfill the block template, and the Merkle root, which is a field of the block header, of course, depends on the transaction put here. But by the way, this list of transactions nowadays is fulfilled and chosen by just the pool operators. So there is a very centralized point there. And that's the reason, one of the reasons why Stratum V2 4 years ago came in. So it was originally designed and proposed by the co-founders of Brains and Matt Corallo in 2020, and it basically is a authenticated and encrypted version of Stratum. And of course, it is also even more efficient than Stratum V1 since it changed the JSON RPC with a binary framing. So there is no more JSON encoding, and it is more efficient for that. And of course, one very strong point that we are pushing with Stratum V2 is the fact that the transaction selection process will be more decentralized, hopefully. So in addition to Stratum V1, of course, Stratum V2, it is an open protocol developed by community. And so for that, it has been developed since now in a very modular way, and it is a flexible protocol as well, as we will see later. So just to remind better and to point out the transaction selection process, right now, as you can see on the left, these are the miners, of course, the mining devices. And on the right side, there's the mining pool server, which is, as you can see here, the entity connected to a Bitcoin node, where the mining pool server, of course, take the transactions from the mempool, fulfills the template, the block template, and send the block template to the miners downstream. So what it implies? It implies the fact that since the transaction selection is performed, as we already said, by the pools, this chart, which represents the aggregation of hash rate in mining pools, is the same chart for the transaction selection. So what does it mean? It means that basically there are just 10 or 12 at maximum entities in the world, which are the ones responsible for selecting the transactions and fulfilling the blocks, which is not a very good point in the decentralized nature of Bitcoin. So with Stratum V2, as you can see here, I underlined the fact that miner side, there's another Bitcoin node, which is called template provider, since it's the node which is used by the miner from his side to create custom block templates. So to select transactions from the mempool and create custom block templates in order to be used to work on it. So this little change, of course, implies a very huge change into the transaction selection chart, as you can see on the right, because at that point, if every miner will be using its local template provider to build its custom block template, the chart about the transaction selection will be looking like this, more or less. So that's the decentralization point about Stratum V2, basically. So here we are. Finally, we will talk about how Stratum V2 is structured. So basically, there are three main components of our project. The first one is the SRI, so the Stratum V2 reference implementation, which stands for the main open source implementation of the Stratum V2 protocol specification. It is written in Rust, and it is, of course, the main point of our work, where we put the main work, basically. Then there's, of course, as already mentioned, the SV2 protocol specifications, or just specs, which basically is the repository where every messages and every interaction between the roles are defined and specified. And finally, there's the third repository, which is the website repository, so that our documentation, specifications, and more in general, or what required, or what is linked to communication, we use this repository in order to update our website to manage that. So after having seen and analyzed which are the main repositories of our project, let's see how to start contributing to our project. So we just add to our repository a document called contributing.markdown, which basically tries to wrap up everything is needed for newcomers to start contributing to our project. And we basically, try to put there material and, of course, prerequisites and stuff like that in order to start contributing to the project. So that would be a very good reference for you all. And the second thing, of course, for anybody who is interested in starting to contribute to our project, jump in our Discord server, as you already did, since the main communications about our project is done there, of course. Another very important point, in my opinion, about before starting contributing to SRI is to understand, going into our website, what are the possible configurations of SRI itself. So let's follow that link, go on stratumprotocol.org and try to explore the website, read some docs there, and at the same time try to link what you are reading and studying with this very good explanation and graphs of configuration. So you will, in this way, you will link the roles that will be mentioned on the specification and on documentation as well with the real implementation. And of course, a very, very important piece is trying to getting started with the project, following this guide mentioned here. Following this, you will be able to run every role or just some roles, and it is a very important activity to do while starting to contribute to the project, since, as you already said, in this way you will be able to link what you will be studying in the meantime to the real implementation. So we are approaching the end of these slides, and as every other open source project, you can start by just looking at this material, as I mentioned, and maybe start working on some specific tasks, going through the issues already opened on our repositories, and start by doing the good first issues, of course. But if you want to join us in some already defined sub-projects, here we are. This slide tries to wrap up what are the current sub-projects and who are the mentors for that. So, for example, I am working on a benchmarking tool, which will be able to track metrics and compare, of course, the protocol performances between Stratum V2 and Stratum V1. So I'm just started to build this tool, and of course, if anybody of you is interested in giving me a hand on it, it would be a really pleasure, and I would mentor in this sense. The same thing applies to the so-called message generator, which is basically an interoperability suite built by Lorenzo, which is able to, basically test in a very specific way our current implementation, but also some future different implementation of Stratum V2. So that's a really important project. And of course, if anybody of you will be interested in diving in, let's chat with Lorenzo follow the link. There are some links here just to our GitHub profiles, and feel free to ask him how to help him with this message generator. And another important sub-project is the prop and fuzz test and the FFI as well. So Plebesh, which is the guy here, is starting to work on this, and he will definitely need some help on that since it's a lot of work. So again, feel free to ping him. He will try to mentor you as much as possible. And at the end, for anything which is related to our website or any documentation improvements in general, feel free to ping Pavlenex. He will help you on board, of course, on the website repository and helping you reviewing your future possible improvements to our current documentation, etc. So these are the current sub-projects which we are working on. Okay, here there is just a slide with the references and some really useful material. As I mentioned during the presentation, in my opinion, one very important thing to do before diving into the project is reading and try to study the protocol specifications, which are linked here, since they are defining every message that you will encounter in diving into the real implementation. So having an overview about the protocol is needed, and Stratum V2 protocol specification is just that. So I would start from that. And as I already said, the Getting Started guide will, of course, clarify many things by guiding you into the real implementation. And then there are, of course, other materials. I did the master degree thesis last year, which is, of course, linked here. There's also a PDF where you can start studying on, and it covers, like we tried to do in this presentation, since the beginning, what is Bitcoin mining, what is the pooled mining, why there's these many mining pools, how the miners are operating, which are the protocols, and of course, the core thing of the thesis is about Stratum V2. So there's another, this is another good material to read from, or you can, of course, go to the playlist, which is done by Plebesh, which tries to summarize with some very, very well done videos, basically some chapters of my thesis. And it is really recommended also to have a look at those videos while studying the protocol specifications and diving into the project itself. So here we are. The presentation is done, so feel free to do any question you want.
Do you when this protocol is implemented in the wild, do you think that the miners will provide their own templates, or do you think there will be third parties providing the templates?
That's a good question. And of course, we hope that the templates will be provided by local template providers. But yeah, protocol doesn't require that a template provider is needed to be run locally. I mean, a third party could be used by protocol. But in my opinion, but it is just my opinion, the best thing would be to run it locally in order to get all the efficiency improvements, and with regards to not having to wait to the from the pool to send your template to you, basically. So also involving a third party, it would be more or less what is already here with the mining pool, which provides you the template you are working on. So, but it's my opinion. I mean, I will, for example, with the benchmarking tool, I will push a lot on trying to measure in a very precisely way the improvements which regards to the latency that you save, of course, if you work with a local template provider. But yeah, it could be done locally or by using a third party or without creating a custom template and just relying on the pool one. It's, as I said before, it's the protocol is very modular, and so let's yeah, basically everyone to use it how they want.
How long do you think it takes to compute a template locally?
I got some measures, but they are pretty naive, and it's like I don't know, some milliseconds. But yeah, it could be more than that.
Could it be comparable to the latency of just requesting one from a third party? I know it's a pretty speculative question.
Yeah, the fact is that imagine as soon as a new block is found, right?
Mm-hmm.
If you have your local template provider, you will notice them immediately, and also the third party will notice that immediately. But the latency in that case is added only if the third party would need to send you the new template. Mm-hmm. So a new block is found, a new template is built. The same time, of course, is taken by the third party and by you locally. But if you have it locally, you don't have to wait the new template to be sent by the third party. That's the key thing, in my opinion. But yeah, I don't have measures to be shared now. I don't know if you followed me. I hope so.
I don't know either. Let me check. I'll be sure to follow you.
Okay. Yeah, there's a. I mean, if there is some question which regards to contributing, or yeah, how to contribute, or anything we can help, feel free to just unmute yourself and speak.
I have a question around reviewing pull requests. So let's say someone has fixed an issue, right? How and you'd like to review the PR? How would you go about that? Especially since for new contributors like us, because I'd love to review a lot of PRs and see how kind of like understand the project in general so that I can know how best I can contribute. So I have a question around PRs.
Yeah, reviewing is a very important thing in open source, especially. So it would be really needed, of course. But first of all, before reviewing a PR, of course, if this PR affects like important pieces of the protocol or the implementation, of course, you would need to be aware about how that piece of implementation really works. So, but you can look, for example, if a PR is opened and it tackles like a very small pieces of the protocol, you can just try to do the review by using the GitHub, of course, interface and providing your review. But yeah, if you want to try to review some very big PR, of course, you would need to really understand the code that you are reviewing for sure. But I don't know if I answered your question.
Yeah, you did. Thanks.
Another point, I don't know if you already know, but our work is weekly updated. So basically, we do a dev call every Tuesday at the same time that we did this call today. So at 6 p.m. Chest time zone. And it's a dev call which lasts 1 hour. And yeah, we basically update ourselves weekly, on a weekly basis. So every week, everyone tries to update the other members of the community, and we try to push forward and defining roadmap and stuff like that.
I see some good information to review there. The dissertation, the specification looks like it has some very good diagrams for the code structure, how the messages are passed, and which objects they're coming from, and so forth. And the contributing doc explains how to, like, basically the development loop for pull requests, make sure that they're tested and linted and formatted correctly. And then it goes on to say, look for the good first issue tags, and I don't know what this help wanted link is. I guess that's another label for issues. Have the issues been reviewed for staleness since the SRI 1.0 came out? I know it was mentioned a couple weeks ago on the dev call.
Yeah, they already have been reviewed. I mean, the issues, but we will do another round of review about them in order to be completely sure that the issues which are opened are real issues at this stage. But yeah, Pebesh particularly have done a big work onto trying to label the new issues and the old ones especially as good first issues or not. But we will do for sure another round of check so that you can start by basically dig into one good first issue that you see.
Okay, great. Thank you.
You're welcome. And yeah, of course, the presentation we followed here will be shared for sure on Discord. And yeah, as I already said, and also Jim Ballock mentioned, the contributing document, which I can send also here, basically wraps up everything you will need to know before starting to contribute. So that this is a very good reference to contribute in general. And yeah, also trying to answer a question by Pavlenex on the chat. PRs and work in general is in a way prioritized based on our current roadmap, which you can find at this link I just shared on the chat. We try to follow a roadmap and in order to define what issues and what PRs are, of course, more important than others in specific timeframes. So the roadmap is, of course, also linked in the contributing document. And I think that it's a very important point where to look in order to understand the project direction and issues which needs to be tackled before others and stuff like that. So I would encourage you to have a look at the roadmap as well. And yeah, as Lorban said on the chat, a very good practice is to declare the issues that you want to address before starting to address it. Since we are many people, it could happen that you start working on an issue and another people start to work on the same issue one day later. So if you start to work on issues, of course, try to communicate that with others. And
Okay, Kitka, thank you for the explanations. So I want to ask, I know there are path you mentioned that we can follow, and we have mentors to guide us. Um, how would the mentoring be, and um, which is more which is more prioritized? Is it the we doing the mentorship, or we working on the um first issue, first good fit issues?
I would say that there's not a specific priority between them, or better. The projects I mentioned are really important. So the benchmarking tool, the message generator, the tests, the FFI are, they are prioritized in the same way, I guess. But at the same time, also working on already open issues is really, really important to keep improving the code base and clean up old stuff in general. So there's no, more important thing between them at all. It really depends on what you, are more comfortable to do. I mean, if you already know Rust and you want to, for example, explore Stratum V2 by yourself by studying the resources we provided you, and by getting started through the guide, etc. And in the meantime, you want to just have a look at the code base and start working on something, but you don't know exactly on what, you can just check out some already open issues and start working on that, on some good first issue, of course, at first. And so that you will try to, put your hands on the implementation, and
Okay, thank you. Okay. About I remember when I was working on one of the good first issues as a readme. We had um when we want to push the code base, you have to run some tests. So while working on a good first issue, do we also need to consider the unit testing, or is there a particular command to use and run that so that we can ensure that everything is good to go before we push to
yeah,
the branch?
yeah. And I would say that is everything described in the contributing document I mentioned before. Also this part. So for example, you start by tackling an issue, you push some commits, but before opening a PR, a very good practice is to run the test locally and see if everything is fine. And the commands to do that are also described in the document. So if you are willing to tackle some good first issues, you can just follow and read before maybe the contributing document, so that you can also try by yourself locally to run tests and stuff like that before, of course, opening the PR, or in the meantime, I mean. And to complete what I tried to answer before, as Pavlenek said on the chat, good first issue generally are not time bounded or prioritized in a specific way. So, of course, for new contributors, trying to tackle them is a good thing to do, for sure. So that maybe you can take, for example, more time and work on them in a more relaxed way, let's say, because those good first issues for sure are not issues which are influencing our current roadmap. So you can also take more time to fix that.
Okay, thank you.
You're welcome. Okay, I don't know if the other core contributors have something to say. If you want, feel free to unmute yourself and speak. Otherwise, I would just close it if nobody has some more questions. Okay, so now Lorban, go.
Sorry, I am Lorban, and I won't take you that much time. I am another contributor for the SRI, and I would like to share you a sub-project of the SRI that dealt about the reward method for a non-custodial pool in which several ex-contributors have worked some time ago. That is in a kind of it is kind of dormant right now because I mean it doesn't always have time and to, to to keep going with it. So if someone is interested, I share here the link, and it is basically a proposal for a payout method for a non-custodial pool. So it is a research. If someone has the will to review it or have a look at it, would be great. This is just a very minor thing that I wanted to mention.
Okay, so sounds great. I would close the call now, and yeah, as always. But I guess I'm pretty sure that everybody here already are in our Discord. But yeah, most important thing is to be updated using our Discord, basically. So stay tuned there. Material I used to do the presentation will be shared somewhere there for sure. And of course, tomorrow there will be our weekly scheduled dev call. So if anybody is interested in joining it, feel free to join for sure. And yeah, for anything else, feel free to discuss any doubts or question you might get in these hours on the Discord thread that was already created. Maybe we will create also another channel for like new contributors or something like that. But for sure, stay tuned using our Discord server. And yeah, thank you all for being here. I hope it was helpful for you in order to get involved, and hope to see many of you in the next weeks for sure.
Thank you, GitGov. Thank you, everyone.